All right, let's take a look at doing some graphing stuff in here. We can both look at both logs and exponentials because they work very similarly to each other. This is like 4.2 and 4.3. And it's already dying. And I'm off the screen. That's good to know. So if we have something like y equals 4 to the x, an easy way of going about doing it until you get the pattern down is just plug in values 0, -1, and 1 and see what you get. Here we have 4 to the -1, and recall that negative exponents mean flip the fraction over and have the same exponent on bottom, but that's possible. So this generates the point -1 and 1/4. If I put in 4 to the 0, anything to the 0 power is 1. So we have 0, 1. This one doesn't change, period, for any of the exponentials. Doesn't matter if it's 1/2, it doesn't matter if it's 3 million, anything to the 0 power is 1. So 0, 1 is a plot point on every single exponential graph, unless it's shifted, unless we have something like x - 2 or something in that, when it's just straight to the x power, that's always there. And then if we do it to the first power, we just get 4. In general, if we did the same thing with a to the x, this is a to the -1, a to the 0, and a to the first power. This just gets us 1 over a. Again, that's still 1. The caveat here is a is greater than 0. And this is just a. Now, while it's true this works for a equals 1, when a equals 1, this is just 1, this is just 1, this is just 1. This is a horizontal line, y equals 1. So we tend to not do a equals 1. We don't have a base of 1 because it's still 1 to any exponent is just 1. And so even if you don't memorize that, it's still the same process of doing it. Put in values, calculate what it is. You'll eventually get used to seeing exponential functions have an asymptote along the x-axis. They have a value at 1. They have value at a. And -1, they have 1 over a. Whatever that value is. As it goes left, it approaches the x-axis. As it goes right up here, this thing starts blowing up pretty quick. Because if I put 2, 3, and 4, I've got a squared, a cubed, a to the 4th power. So if like a is 10, when x equals 4, a is 10,000. This graph just skyrockets super fast. So that's why we tend to only graph one in either direction. So this blows up super fast. In the other direction, it goes to 0 super fast, but never is actually 0. Everyone ready for more? This doesn't change hardly at all when we have a to the x minus h plus k. Yeah, something that goes like that. That's my default a to the x. Let's say this is at a and this is at 1 over a. Start getting that one too. Just like we did with the other graphs. This thing, when we do the opposite sign value here, this means just move everything right h and up k. And if I try to do that same thing, not quite hard. Let's see, this is gone. Okay, yeah. So what we had over here, we had an asymptote at y equals 0. The HA was y equals 0. When it shifted, the HA is y equals k. You could even do a nice little new plot here. Rather than centering it at -1 and 0, -1, 0, and 1, now you're better off doing h minus 1, and h plus 1. You'll see when we stick in h, we have h minus h plus k. A to the 0 is 1. This gives me 1 plus k. Which makes sense. If the asymptote is along k, then going up 1 from it will get us the same thing. This isn't worth memorizing. It's much better to just move the graph and go up. But if you are one that likes doing that stuff, this equals 1 over h plus 1 over a plus k. A plus k. So that's showing that we had to move right H. And move up K. Obviously, if it's H is negative, means we go left, not right. And if K is negative, we go down. So let me give you guys one to try. I'll do that. And then we'll graph it together. So there's two approaches. Doing the movement thing like we talked about. Let's do that first. I should have a point at 0, 1. My base is 3, so I will have a point at 1, 3 for the default one. And then at 1/3. Now this says move everything right to. So I need to add 2 more and I need to go down 4. Going down 4 should put that asymptote right here. And let's move those points down. And right, we're gonna go right 2. And then down 4 should be 1, 2, 3, 4. That's my center point. I'll do that one in green. And then this one's gonna go down 4, 1, 2, 3, 4, and then right 2. And this one is down 4 as well, which is right above the asymptote. And right 2 is going to put it right there. We have something like that. Alternatively, when you have values rather than A and H and K, doing the chart here isn't too bad. You just have to remember the center of your chart at the value that makes it 0. So x minus 2 would be 0 at 2. And then we'll go 1 lower and 1 above. So this is 3 to the negative 1 minus 4. So 1/3 minus 4. Negative 3 2/3. And then this is 3 to the 0 minus 4. 1 minus 4 is negative 3, so we can see. And doing this one is 3 to the first minus 4. 3 minus 4 is negative 1. And so then you would have the points 1, negative 3 2/3, 2 and negative 3, 3 and negative 1. That make this any easier?
Yeah.
Did you get this graph on your own?
I didn't get to graph it, but I know it's right. Whenever I just did like y from x and then y equals 3 are x. And then I did negative 1 and I clicked in backwards and it goes.
Okay. All right, let's do another one to make you graphic. You got it?
Yeah.
All right. Moving it. +1 tells me I'm gonna have an asymptote actually where my old 0, 1 point was. My points were 2 to the first power would put me right here. And -1 to the 1/2 is that actually makes it pretty easy. Now we're gonna shift it. And we need to make sure that we shift it left 1 and up 1. So that one's gonna go over 1. I guess I need to add another hashtag here. Another hashtag here. This is gonna go left 1 and up 1. This will go left 1 and up 1. And this go left 1 and up 1. So that's where we start curving and going to infinity. And that's where we start tapering towards cloud. All good? All right, let's take a look at a log before we run out of time. How you guys doing online?
I'm following.
You following? Okay. So logs aren't a whole lot different. Remember, this is the same thing as x equals a to the y. So maybe we'll do one where it's log base 2. And this is x. And then we can look at what log base a does. This effectively means I'm looking at x equals 2 to the y. So here it's a little bit easier to plug in if you're doing the table, plugging in the y values, picking 0, -1, and 1. If I have this is x equals a to the -1, that corresponds when x equals 1 over a. When I do y equals 0, I got x equals 1. Not a, 2, sorry. And when y equals 1, x equals 2. If we do a -1, 0, and 1 on the a, that's where we have the 1 over a, 1 and a. And I think it's kind of worth pointing out. Let's look at the exponential one. We had -1 and 1 over a, and now we have 1 over a and -1. We had 0 and 1, and we have 1 and 0. We had 1 and a, and now we have a and 1. These are inverse functions. So for inverse of y equals a to the x. So whenever you have an inverse like that, the domain and range flip. That goes to that one, and that goes to that one. As we just saw. All my x, because and recall, domain is x values. My x values now turn into my y values. And my y values turn into my x values. So the plotting does the same thing. The only difference is log looks more like this now. Where we used to have a horizontal asymptote at y equals 0. When we swap this, it now says there's an asymptote at x equals 0, which means it's a vertical asymptote. Oops. And we saw when we had x was a, y equaled 1. When you've done enough of these, this becomes second nature. This is also subject to the same shifting that the other one is. Now it's x minus h, and the x minus h is in parentheses, and then plus k. And sometimes you'll see it where the k is first, simply because it makes it clear that sometimes they're lazy as fuck and don't want to put the parentheses, but they should. This kind of makes it clear that the k is definitely not part of the logarithm. It still does that HK shift. The only other thing that's tricky is when a is between 0 and 1. And 1. So like let's do x, and then y equals 1/2 to the x. So back to the exponentials real quick. You still do the same thing. Oop. And conveniently, the center doesn't change no matter what. And then sticking 1/2 here to the -1. -1 says flip it, and I get the 2. So I have -1, 2. And when I do 1/2 here to the first power, it's just 1/2. So I have 1, 1/2. Zero, 1 still in the same spot. But -1, 2 is up there. And 1, 1/2 is down here. Which means it goes downhill to the right. The reason why this is it basically mirrors over the y-axis. From y equals a to the x. The reason why is this is the same thing as 2 to the -x. If I just shift it right there. And that's something that happens in the stuff. It's a little harder to see in a lot of it. But the negative inside that thing actually just changes flips it across the x-axis or the y-axis. It might be easier to do it as is, because looking at 1/2 gets a little bit confusing, or can. But if you're doing it here, when you stick in -1, 0, and 1, you're looking at a whole number. And so you might have an easier time with it. And the way that affects the logarithms. This is like x equals 1/2 to the y. Or 2 to the -y. So if I put this back in that form, I got -y equals log base 2 of x. So y equals -log base 2 of x. That's kind of interesting. These two are the same. And this might be the easier one to look at. Still have at 1, 0 point. And this would be at 2 and 1/2. The regular graph is like that. Log 2 of x does this. So when we do log 1/2 or -log 2 of x, it mirrors across the x-axis. Which makes sense because it's doing the inverse of what the exponential does. The exponential mirrored over y, and when we switch y and x, now it should be mirroring over x. Which means this comes up here, and that comes down here, and that stays in the same spot. And we have that. And it's almost 3 o'clock. So we'll take a break here.
So the green line is,
The green line is the log 1/2 x
so
or negative log 2x. It's a neat property of the logarithms that you can switch them around and look at seeing similarly. This actually happens a lot. If you're doing like. This happens an awful lot, log of 1/2 or like log of. Shit, anything. 1/a. Or ln of 1/5 kind of thing. Any number on bottom, if the top is 1, the properties of logarithms, when we do the division, it turns into subtraction. And both of these are 0. So we're just left with negative log 5 and negative ln of 5. Another way of looking at that is rewriting this as log 5 to the negative 1. And using the exponent rule where we pull the exponent down in front.